Welcome to Biostatistics NW395N, Section 88120. Today we're going to talk about hypothesis testing, and your instructor is Dr. Marge Benham-Hutchins. So the learning objectives for today's lecture on hypothesis testing is to describe the purpose and process of hypothesis testing, understand the place of hypothesis testing in evidence-based practice, learn how to correctly state hypotheses, distinguish between one-tailed and two-tailed tests of significance. We'll talk about type 1 and type 2 errors and how to describe and distinguish them. We'll talk about effect size and the relationship to statistical and clinical significance. And then we'll talk a bit more about the differences between statistical and clinical significance, and then a little bit about statistical power and the importance of having a well-powered analysis for your research project. So let's start with an example. Suppose you have a study where you're going to try a new intervention to prevent falls and see if it's more effective than your existing approach in reducing fall rates. So the effect is what exists when changes in one variable cause another variable to change. And hypothesis testing is the process where you use scientific decision making to determine if the likelihood of the difference in a variable is not due to chance. So there are 7 general steps in hypothesis testing. First, you want to state the null and alternative hypotheses. You need to choose the level of significance. You need to propose an appropriate statistical test. You need to check the assumption of the chosen test. You're going to compute the test statistics. In other words, you're going to run the statistical analysis. You're going to find your critical values and then compare the test statistics and the critical values to make conclusions. So step 1, you're going to state the null and alternative hypotheses. So this means that in each study, you're going to have 2 competing hypotheses. They're going to be mutually exclusive. Both of them cannot be true, but they're also all-inclusive. One of them must be true. And one is called the null hypothesis, and the other is the alternative hypothesis. So the null hypothesis is the hypothesis with no effect, and the alternative hypothesis is the hypothesis that states an effect. So the next thing you're doing is choosing your level of significance. And this is what we discussed in class on the p-values. And there is a document that I put on Canvas that are some resources to help understand p-values. But basically, the level of significance is the criterion used for determining statistical significance. And it's determined by the researcher in advance. And this has to do with the researcher's comfort level. And this is going to be driven by the type of research that is being completed. For instance, social science research, quite often it's 0.05 because the researcher is comfortable that they will reject the null hypothesis 5% of the time incorrectly. In other words, they're comfortable with a 95% chance that their hypothesis is correct. So your next step is to propose an appropriate statistical test. It's critical to know the number of variables and the level of measurement for each variable when you're selecting the appropriate test. For example, if you are looking into a relationship between 2 variables, weight and systolic blood pressure, and both are measured on the ratio level, then you would be looking at using a Pearson's correlation coefficient. Selecting the appropriate statistical test is very important, and it's also can be rather complex, and it's also very dependent upon the type of research that you're doing. So I have listed here a few resources for selecting the correct statistical test. Appendix B in the Kim and Mallory book provides information on how to select the right test. Table 7.1 in the Kim and Mallory textbook provides an overview of the number of variables and level of measurement in choosing a statistical test. And then the Cronk book, inside the front cover, there is a algorithm on what is your main question, and it leads you through a set of decisions in order to lead you to the correct test. I have also posted in Canvas an article on choosing statistical tests that has been that I think you will find helpful. So for each statistical test that we are discussing, we will include a discussion on assumptions. This is very important to be aware of when you're selecting the statistical test for your particular research project. Each test is going to have unique assumptions, but the common assumptions across tests include the normality, equal variance across groups, and independence. But be sure to check those assumptions for each specific test. And as I mentioned, we will be discussing that as we go through the different tests as we move forward in the class. So steps 5 and 6 are running the test and finding the critical values. These will vary by the statistical test, and we will discuss them when we are discussing the specific test. Appendix C in the Kim and Mallory textbook has tables for critical values for all the different statistical tests. And this here is just an example of critical values when you're looking at confidence intervals, which are sometimes reported for some types of statistical analyses. So step 7 is where you're going to compare results and make conclusions or draw conclusions. So you will be examining the probability of the effect, which is the p-value, as greater or less than alpha, where alpha is the level of significance, and where p-value is the probability that a statistic is significant. So statistical decisions are made based on the comparison of the two. You reject the null hypothesis in favor of the alternative hypothesis if the p-value is smaller than alpha, and you do not reject the null hypothesis if the p-value is greater than alpha. It's important to realize that you are making your decisions based on rejection or accepting the null hypothesis. So you reject or do not reject the null hypothesis. Never make the decision with the alternative hypothesis. And this has to do with the types of error that we'll be talking about shortly. So now we're going to talk briefly about one-tailed versus two-tailed tests of significance. So this has to do with how the hypotheses are written and if they are written with a direction or difference. So if they are written with no direction or difference, the test is said to be two-tailed. So your null hypotheses would be there's no difference in fall incident between the newly developed approach and an existing approach. And your hypotheses would be there is a difference in fall incidence between the newly developed approach and an existing approach. And you could see here from the distribution graph that the two-tailed test has p-values that are looking at probability in both tails of the test in both directions. So now let's talk about one-tailed tests of significance. If the hypotheses imply direction on top of possible differences, then the test is said to be one-tailed. You can have a right-tailed test or a left-tailed test, depending on your hypotheses. So if your null hypothesis is the average number of falls is equal to 13, and your hypothesis is the average number of falls is less than 13, this is directional, so you need to do a one-tailed test. Kim and Mallory on page 154, table 7.2, have some language for writing one- and two-tailed hypotheses that I think you will find very useful. So when you're doing hypothesis testing, there are two types of errors you need to be aware of. Type 2 error, which is often called beta, type 1 error, which is alpha. These errors, type 1 error occurs when the null hypothesis is rejected when it should not be, and type 2 error occurs when the null hypothesis is not rejected when it should be. So an example of a type 1 error for our example study that we've been talking about would be concluding that the new fall intervention is more effective than an existing approach when in fact they do not differ. So that would be a type 1 error. And you need to think about the clinical significance of making that type of error. Type 2 error would be concluding that the new fall intervention is not effective when in fact the new approach is effective. Most people are more concerned about type 1 error and say it's more serious. But I think when you're doing your research, you need to think about it. Think about these types of errors and which one would be worse and which would be more significant. So they are, type 1 and type 2 errors are inversely related. So if the investigator sets the level of significance p-value too low to decrease the likelihood of type 1 error, then the likelihood of type 2 error increases, saying there's no effect when there is one. So this is a balance that you need to know, and many times you could talk with a statistician based on your study and what you're actually studying. Increasing sample size is one way to control for both types of errors, as it brings the sample size closer to the population. But these are things that you need to consider particularly when you're evaluating your statistical results. So another thing to consider is the effect size. This is the measure of the strength or magnitude of an effect, difference, or relationship between the variables, which is basically has to do with your statistical results. So even if you get a statistically significant result, you must be cautious in interpreting the results. And sometimes a study can be repeated, can be very similar, and in one they get statistical significance and another they don't. So it's really important when you're doing your evidence-based review that you look to see if the findings are consistent across studies. And the statistical significance does not tell us much about how much of an effect was present. In other words, how large is the effect and how important the size of the effect is in practice, which is what we call clinical significance. So the next thing we need to think about is statistical power. That's the probability of actually rejecting the null hypothesis when it's false, or of correctly saying there is an effect when it exists. Higher power is desirable in most situations, and there are a variety of things that influence power. The level of significance, what we've talked about, the effect size, the sample size, and the type of statistical test. So right now we're going to talk a little bit about sample size, because this is really important, and there's a variety of ways of doing power analyses in order to determine the correct sample size. So there are two different types of power analysis. A priori power analysis that's conducted before the study is conducted, and it's a guide for estimating the sample size that's required to reject the null hypothesis. And also post hoc power analysis. So this is done after the study is completed and tells you what level of power the study was conducted at with the obtained sample along with other factors. So in other words, the first one is your goal, your sample size goal, which is what you will probably discuss when you're designing some of your studies, like how many people do I need to have in the study to make it a good study? And that's the a priori power analysis. The post hoc power analysis is not done quite as often, but it may be done in addition to the a priori, and it's after the study, and it tells you more about the actual study itself. So power analysis is something that there's a variety of ways to calculate it. G-Power is very popular for people who do a lot of research, and you can download the free version to your Mac or PC. There's some online versions, and I've given two different links here. One of the things that's important to remember, and if you are doing a quality improvement type of project, then you're going to approach power analysis very different. And that's that if you're looking at a particular unit and there's 25 people that work on that unit, your power analysis will help you determine how many of those people you need to have respond in order to have the study results to be valid. It's not the general population, because you already have a bounded population. So it's not all nurses that work on a med-surg unit, it's the nurses that work in that particular unit. So when you approach this, think very closely about how you actually what type of study you're doing and the sample that you really need to get and the sample you have access to. Another example might be that you're looking at a particular thing with burnout in oncology nurses, and you're looking at surveying all the nurses that are a member of an oncology organization. Well, if there's only 500 people a member of that organization, then your power analysis would be how many of that 500 do you need to get to have an accurate sample, but then your findings are going to be specific to that population, where you're going to say that in the case of a particular unit, it's not necessarily generalizable to other units. So there's some big difference between quality improvement and research that you need to look closely, particularly when you're looking at some of the statistical tests and how you're going to run them and how you're going to design your projects. You need to be really clear about that and talk to your advisor. The main references used in this presentation are the Cronk book and the Kim and Mallory book. But as I've mentioned before, the Andy Field book, any of the editions, Discovering Statistics Using SPSS, is a bit more advanced than the Cronk book, but walks you through a lot of statistical tests. So if you're planning to do regression analysis or any other complex statistical tests, then I would recommend that you get a copy of Andy Field. And I think you will find it's worth it. In this presentation, I also provided links to a variety of resources.